In today's session, we will see the experiment based on the function generator and oscilloscope. So this is the function generator that is used to generate the different types of the functions with change in amplitude and change in frequency. In my both sides, there are oscilloscope. This oscilloscope is the analog oscilloscope, which is known as the CRO, and this oscilloscope is the digital oscilloscope, which is known as the DSO. So this type of the oscilloscope is generally used to analyze the different types of the waveforms of any particular circuit. Now let us see the experiment based on this device. Today we will see the experiment based on the function generator and digital storage oscilloscope. So first let us see in brief about the function generator. So let us say that you want to make one project, and in that project you require the different types of the waveforms like sinusoidal waveforms, square waveforms, triangular waveforms, ramp waveforms with change in frequency and change in amplitude. So to generate such kind of the waveform, we prefer to use the function generator. As you can see that in this function generator, we can generate three different types of the waveforms like sinusoidal waveforms, square waveforms and triangular waveforms with change in the frequency starting from 1 Hz to 100 kHz and change in amplitude. So what we will do, we will generate the different function in this function generator and we will see that particular function in our DSO. So now let us say I have generated the triangular waveform. So here you can see this triangular waveform. So as I will change the frequency, you can see that now the frequency is changing. I am increasing the value of the frequency. Similarly, I am decreasing the value of the frequency. So any type of the signal is possible starting from 1 Hz to 100 kHz. Now let us say I want to change the amplitude. So just you need to change this amplitude button, and as you will change, it will goes on increasing and goes on the decreasing. Okay. Now basically this is our DSO, and the main aim of this DSO is to see the different types of the waveforms like input waveforms, output waveforms, or the waveform across any branch or any element. So now let us see how to use this DSO. So basically there are the different types of the function as you can see in our DSO. So this function is basically for volts per division, means if you want to increase the magnitude of the signal in vertical position, that we say volts per division. So using this button you can use, or you can do this volts per division. Now let us say I want to move this waveform either in the upward direction or in the downward direction. So for moving the waveform in upward or downward direction, we make use of this function. So as you can see, as I am moving in the clockwise direction, the waveform is moving in the upward direction, and as I am moving in the downward direction, the waveform is moving downwards. And similarly, like vertical position, we also have another type of the position, that is the horizontal position. This horizontal position is basically used if we want to do the time per division, means if you want to increase the frequency of this particular waveform, then we need to use this button. As you can see, as I am moving in the clockwise direction, the time or the frequency of the waveform is increasing. Similarly, if I am moving this in the anti-clockwise direction, you can see the time or the frequency of the waveform is decreasing. So this is basically used to analyze the signal in the best way. Now let us say when I have connected this oscilloscope to any circuit, I am getting this type of the waveform. Now this waveform is very difficult to analyze. So how it is difficult to analyze? I am not getting what is actually there in the time per division. So actually I need to use this, or I need to increase its time per division. So simply I will use, or I will move this in the clockwise direction. Similarly, if I want to move this waveform in the right direction or in the left direction, I need to use this button. As you can see that it is moving in the right direction, it is moving in the left direction. Basically I am having two channels, so this is a 2-channel DSO. So the number of the channels shows how many output can I see at a time. So here at a time I can see 2 outputs. So this button is basically used for changing the brightness. So as I am changing it, the brightness or the intensity is also getting changed. Another options we have save and recall. So now let us say I want to store this signal into my pen drive or other devices. So simply I need to use, or I need to insert my pen drive here, and after inserting, just I will choose this option, save and recall. The waveform will get stored in that particular device. Another option is of the measure. So this button is basically used for taking the measurements of the signal. Now let us say I want to take the maximum value of the signal, minimum value, time period, frequency, any such informations you can get by just pressing this measure buttons. Then we have the cursor button. Basically this cursor button is used when we are looking two waveform at a time, means we are using two channels at a time. Now for example, I want to check what is the difference between the frequency, what is the difference in the amplitude of the two signals, just I will press this cursor button. So this is used for the measurements of the, or taking the difference between the two signals.